Perhaps until today you still don't really get what is all the formula that you see all the time, but you were not able to memorize them, like this, like that, or even this one. It's very seldom people have a very deep impression of it. Okay, so how do we get all this in the first place? Let's find out how to prove them. But before that, I also want to add another one. I also want to add another formula, which is A equals to V minus U over T. Acceleration. Acceleration gives us a sense of when you are slow here and then suddenly you become faster. But how you become faster, within how much amount of time, is also important to find out. Okay, this is slow, this is fast. Okay, let's compare an F1 racing car and Kanchiu. F1 racing car can speed up from 0 to 100 in, let's say, 5 seconds. But this Kanchiu 0 to 100, you might have to take 70 seconds to achieve that. So time is also a factor here in the acceleration. So this is what I highlight. Time is also involved. But so let's investigate who they are first. First of all, S is displacement. We would rather want to call it displacement rather than distance, because in Form 4 physics we study displacement as a distance with a certain direction, because it is vector quantity. And then you also have U equals to initial velocity, and then you also have V as your final velocity, and then A is your acceleration and T as your time. So this one, if you look like this, the arrow, it gives us an acronym called SUVAT. Okay, sounds like so what. So this SUVAT will bring us to the basics of mechanics, the calculations. So what we have here is we begin with this one. S is displacement equals to average velocity times time. An object who is moving at 10 meters per second, and then along the way it goes through a lot of changes, but the final velocity is 20. So we need to find the average velocity actually. It is only an approximation, because we are interested in this and that. So 10 plus 20 is exactly this part of the equation that we are dealing with. So over time, over 2. We want to find average. If you want to find average, you add two things together and divide by 2. So the average velocity is, in this case, is 15. So if you take a certain time frame of 4 seconds, so the distance you cover is actually 15 times 4. Is it logical to use this? Very logical, because this is velocity times time. If you remember your formula, okay, let's draw a blue circle here. If you remember, velocity or speed is a distance over time. So if you want to find distance, we need to take velocity times time, which is distance, and this is velocity, and this is time. But we need to use this appropriately. Okay, this is the appropriate way to use the average velocity. So therefore, we are being introduced to average velocity being U plus V over 2. So with this in mind, we have S equals to U plus V over 2T. But do you remember A equals to V minus U over T? So can I say V minus U equals to AT? Can I also say V equals to U plus AT? Can I put a red star next to V so that I could put it here? by looking at the star, now you know that you should put all the values together inside. I differentiate by using black and blue, and then you see what I'm doing. So in this case, the S has a formula of 2u plus at over 2 times t. So if I expand further, it will be 2ut over 2 plus half at squared. Okay, so if I cut off using eraser this one and this one and this one, does this look like the formula that you have somehow learned before, sometime in your early years of Form 4 physics studies? This one. So you have this one. So that's the first proof. Let's have the second proof. As we have said before, we have S equals to U plus V over 2T. Again, we will employ this, A equals to V minus U over T. But do you realize that if I put T here, I have V minus U over A? Can I put another star here so that you know, by looking at this, you know what to put later? So I have U plus V over 2. The part with the T red star, I will use blue marker, and this one will look like V minus U over A. So if you look carefully, I can rearrange my V plus U plus V become V plus U. It doesn't matter. And this one looks very familiar to what you have learned before, but I want to highlight this part. This one and this one can be multiplied. Not only can be multiplied, it can be brought up. It can be brought up. So what we have here is a 2as. But you also have this part, V plus U bracket and then times V minus U bracket. Do you remember your study of lower secondary, A plus B, A minus B? Does this equals to the A squared minus B squared? If you could remember this, then you know why that this is actually V squared minus U squared. Therefore, again, you will see a very familiar image of this formula. V squared equals to U squared plus 2as. Okay? V squared equals to U squared plus 2as. So you are familiar with this. So therefore I use a red marker to actually draw this for you. Then you know what I'm talking about. Okay, so this part is important. So this two formula is something that we have seen many times and can be used in various situations and calculations, as we can see later.